Swayam Prabha. Digital India. Educated India.
Land use transportation modeling and planning. And today I am here. I'm Professor Devapratim Pandit from IIT Kanpur. And I, along with my TAs who are assisting me in this particular course, Suchishmita, Joyita, Preeti, Dipoman, and Somnath. So we are there as well to take care of your queries. So before even I go into resolving some of your queries, I would like to thank you for attending the course. And it's a course which we have spent a lot of time developing. The course has been designed in such a way so that different types of students as well as professionals, for example, students from the UG level, students from the PG level, and from the PhD level, all get something out of this particular course. And certain parts of the course may seem like a little bit tough for some students, but nothing to worry about. For example, if you are in the UG level, particularly in your course, what you are being taught in your college, along with this course will complement that particular lectures, and you will be able to pick up certain new things from this course, and you don't need to learn every, even the very complicated parts of the course, right? So, for example, if I take the example of demographic models, you probably will limit yourself to the mathematical methods, whereas the other methods you may explore when you are at the PG level. Or if you are looking at the postgraduate level, you may even look at the finer component methods that should be used for doing demographic projections. Similarly, I think another issue that I should start talking at the beginning of this particular session is, in our second module, we have discussed different planning approaches. We have discussed different modeling approaches. Particularly the different modeling approaches that are there, the different urban land use transportation models that are there. So some people have asked us that, okay, why don't we give examples or not? We don't need to at this point. The reason is the modules have been designed to give you a fair idea about what are the different broad approaches that we use when we do urban land use and transportation modeling and planning, of course. For example, we can follow, economic methods. Then there are interaction methods and so on. So these are the different approaches. And whenever we are, these are the different, theoretical approaches. And when we talk about the modeling approaches, we can always model our entire, this urban land use transportation process, again, from different angles. For example, we can use multiple agents. So it could be something like a set of different agents interacting with each other, and the final outcome is, the final land use transportation process. Or we can do something like a micro simulation, or we can even base it on standard interaction models like we do, like using gravity models. So these are the different ways we can approach the same problem, and there are different model systems which have been built. Each of these model systems are built all over the world, and particularly in US and Europe, and sometimes also in the other some Asian countries, people have also built some models. The reason is, each of these models has been built as per their context. The models, when they have developed, each model has got different components, and these components are also based on their own requirements. Then the component design, the approaches that they have adopted, all depends on what kind of data that is available, right? And this data is not like every time I want to apply a certain land use transportation model in a particular city, I will start collecting entire data from the beginning. Because if you want to do that, then it becomes so cumbersome and so difficult to do, you'll probably leave the process halfway. So the thing is, if already there is some amount of data in the city, for example, the census data, that means at the country level, census data is collected, and we can utilize that for developing our models. So if our country collects census data in a particular way, automatically we have to use the data in that particular way. But that also doesn't mean that we exactly have to use it in the way that census has given us. We can also do a little bit of modification to that data, or we can use it in the way we want to, and then we can use it for developing the models that we want to build. So that being said, and even though we have the census data, some other forms of data is required. And for that, usually we do conduct surveys at the city level and all. We can further reduce this. And as you can understand, if I am trying to develop a land use transportation model for Mumbai or Chennai or Kolkata, in that sense, what happens? We have to survey around 1 to 2% of the entire population. So that's a huge, huge figure, right? So we cannot spend so much money on doing those surveys. So instead, if I have some sort of standard data sets already sampled, already we develop a sample and we have surveyed that, and that is, that is also part of the national survey procedure. Automatically, we can use that sample to build a sort of synthetic population for our urban area, which could be utilized to, develop the models that we want to develop, right? And these are the two things that I wanted to discuss about. And in addition, the term micro simulation and all these things, it's kind of scary. That I understand for planning students with certain backgrounds. It's sometimes it seems too much. But the question is, when we are talking about micro simulation, you cannot proceed without that particular procedure if you are going to use utility equations. Now, that means most of the planning models like mode choice, which we have yet to cover, then even for other steps of the model, and even residential location choices and the different choice models that we use. And as you have heard in the previous sessions, that the economic approach is primarily based on this random utility models. So there we require this heterogeneous this disaggregated data. That means we have got the population, that means for a particular individual belonging to a particular gender group, maybe belonging to not only a gender group, a particular income category, with a particular household size, what choice does he make, right? Similarly, if I, the standard, if I know that information, then the prediction of the model will be very, very accurate, right? But census doesn't have this kind of data. Census have data maybe on gender. Census may have data based on your age, but it doesn't have a data on gender for each age group, right? So, or for age group wise, what is the gender division, right? So we have to develop these data sets using some mathematical techniques, and that is where this iterative proportional fitting comes in. And using that, we can actually do a nice disaggregated. We can break our census given tables into disaggregated data, and then using a sample population, we can actually create a synthetic population for this particular area. And that synthetic population could be used to run all our utility models. That means all the utility models that we will develop, we can apply that on that synthetic population, which is more or less representing the population of that particular area. And the outcome of the models would be more and more accurate compared to standard, zone-wise models, where we divide the entire population as per maybe household size. And then for each household size, we determine what sort of trips, people make, and so on, right? So there, what happens? All households of all types, just if it have a certain size, it makes a certain number of trips, which is, it's you can understand that means the accuracy levels would be pretty low. So these are the things which are, our logic model overcomes, or this economic approach overcomes, and that is what we should do, or we should utilize, and that is where microsimulation comes in. And that is why we need to generate synthetic population and do microsimulation. All right. Okay. So I will now take some of your questions. I hope there are some questions coming from the attending students and professionals. We can take some of that, and some questions have already come in. So let us try to answer a few of those. And whatever we are not able to answer at this point of time, due to either time shortage or maybe because of the type of content that has to be explained along with it, so we will put up the information in the forum as well in the coming weeks, of course. So can I ask Shuchishmita or Priti or Joyita, anybody, to put up the questions?
Okay, sir. The first question is, I am not having much understanding about population synthesis using microsimulation. Can this be explained with real examples?
Okay, so yes, we already had a small discussion already started on that. But yes, we will do real examples. What we have done in the module is we have explained the broad processes, and there are several approaches to it. So we have only covered the easier approaches, right? So one approach that we covered is iterative proportional fitting. And then, then what we have done is then using that particular fitting method, then we have done the population, we have determined what sort of synthetic population that could be there. And then we have also talked about optimization approach as well. So both of this method we have explained with some examples, but we will try to work out a example with a small city and a small sample population. Will do that, and then we can demonstrate that in the coming weeks. So that's not a problem. But what I will like to say to you is, I was already explaining that whenever we have, this census tables, they don't have the data in a categorized form, right? So they have data only for, maybe gender, maybe for income group, or maybe for age group, but combined tables are not available. Few tables are available, but not all sort of combinations are not available. But suppose I have developed this regression models or logistic regression models, where we see that a particular person belonging to a particular gender group, of a particular age group, and belonging to a certain household size and of a certain income group is, making a certain choice. And there, that, all these socioeconomic variables are significant, variables which actually helps us to take this particular decision, and it will lead to a more accurate results. So we need to include that. So that is where we need to create this sort of multi-way tables or disaggregate data using the census data set. That is where our IPF procedure comes in, and we have already shown that we can actually develop IPF procedures if we have the control totals for each of the different groups. And then what we can do is, from the survey data for that particular city, which we have to conduct in our Indian scenario, there what we will do is, we will conduct the survey, we will find those small groups of people, that is this, person who belongs to this age group, gender group, income group, and household size. For each of these groups, we will find there is a certain number of people that are there, we will find from the survey, and using that survey data for each of these different categories, which is like the, the initial data, the seed data, we can use the IPF procedure to generate for the actual population, because we have census data which has got the actual data. Using that, we can, or the projected population for future, that again we will have those, that full, this the main data sets, like what would be the gender division. We can use the same as the base year as well. So in that particular case, we can use this procedure, IPF procedure, to actually determine that what should be the division as per the sample, what should be the division of this, actual people in, in that particular data. So now that we have the division, that means for each group, there is a probability. That means, suppose I've got three kinds of categories. That means gender male and income category 1. And then gender female, income category, again, maybe 2. Then gender male, income category 2, and so on. So there are 3 income categories, and then there is male, female. So suppose there are 2 categories only. Now, what happens? We know that every, when we take these 2 characteristics, for each of these 2 characteristics, there is a group of people. So because there is a group of people, we can say there is a probability for that people. That means total, this group, number of people in that group divided by the total number of people, right? So that gives us the probability of that particular population. And now, whenever, we are trying to, create a synthetic population using the sample that we have collected earlier, what we do is we pick up 1% of the sample, and then what we can see is we can list down the entire, this person as per the category of that, and we develop a cumulative probability table. And based on that, and we can do some random draws. That means once we have a list of, suppose 100, samples, suppose that we have collected samples of 100 individuals, right? So we will list them up, and they belong to a particular group. So there is a probability of him getting, selected based on that table that we have created. So we add that probability and form a cumulative probability table. And then we do Monte Carlo simulation, which is nothing but picking up random numbers and seeing that that particular random numbers falls, because probability is between 0 to 1. whenever we pick up a random number between 0 to 1, it will actually fall in one of those groups, and we will pick that population, that particular person or household from that sample, and we will put it in the synthetic population. We will keep on doing that till our synthetic population control totals will match with the multivariate table control totals. So anyway, I understand there are a few steps involved. So these are the few steps that you have to follow when we need to do a synthetic population. So, and then there is the optimization approach as well, where we randomly pick the entire synthetic population for that particular area, and then we keep on removing and adding some new people so that we can arrive at the most suitable result where it matches with that initial table that we have created using IPF. Right. So these are the two methods that we have discussed, and I think this is good enough for our case. These are the most appropriate methods for the Indian context. It's we can always go for other methods as well, but what we felt is this is better because we don't want to go into too many categories, because our census doesn't give so many categories of data. I mean, so many socioeconomic characteristics are not covered in our census. So this is good enough. And if there are more categories, then what happens? There are a lot of cells with zero, number of persons. So in each area, we don't find every category of people. So there are a lot of zeros in there. So this is called a zero cell problem, right? So to reduce that, there is another way we can structure this data set or this information, which is a sparse list. That is also being discussed in the lecture. So these are the three different ways rather we can do that. And these are the things that you can utilize. And what we will do is our team will prepare a small example and we will put up the forum, and then you can follow that, and that you will be able to also generate synthetic populations for a area. All right. Okay. So can I move on to the next question?
Yes, sir. Which model is comparatively better to demonstrate the travel behavior for the urban highways in Indian scenario? And also, I want to know the more precise model to predict urban transportation pattern incorporating the land use pattern in Indian scenario.
I think the confusion with this particular question, I think maybe there is a maybe we are not understanding it clearly. When we talk about the amount of vehicles in a particular highway, basically what you're talking about is intercity travel, right? So that means how many people are traveling from one area to another area, because highways are usually not part of the core urban area, so it connects to urban areas. So that is where we need, when we do surveys, we all not only ask people that, okay, where do they go for work, but if the work is somewhere outside, that means they have to travel to the next city to work, we also get that information. So we have to make realistic estimates about how many people travel outside the city, and that will give us an idea about how many people travel to another, the next cities. And that also, from the mode choice of those particular sampled people, we can also have a understanding of what kind of vehicles are used by those people. But the problem is, highways doesn't connect only these two cities. The highway is a continuous entity, and there are a lot of through vehicles through the highway. That means these vehicles come from different parts of the country and goes to another part of the country. So we have to do surveys also along the highways, and to find how many vehicles join inside from this particular city that you're talking about, or for another where it comes out of that particular, this highway and goes inside a particular city, and what is the through traffic. And based on those proportions, we can determine how much traffic is there in a highway, or how we can project the amount of traffic during a future period. Okay. So this was the first question. The second question, I think, is which model is appropriate. Again, the model depends on the context. Model depends on the kind of data that is available with us. The model depends on what we want to achieve. That means most of the land use, the reason we build land use transportation model is to test certain policies. That means we want to understand, suppose for a particular city, it wants to understand, if I introduce congestion charging, that means if I put certain amount of tolls in the urban arterials, or automatically, because nowadays our cars have got this tags, and if our vehicle passes along those particular streets, automatically some amount of money will be deducted. So if that policy is implemented, what would be the effect on the travel patterns, what would be the amount of earning that we can do, all these things becomes important, right? So our model should be designed to calculate or estimate this. That means there in the certain parts of the models or in the sub models, there would be a role of this congestion pricing, to on the travel demand. That means either congestion pricing increases travel demand or decreases travel demand, or increases travel demand by a certain mode. Suppose it increases travel demand by bus, because bus usually is not put under congestion pricing, is not applied on bus, but on private vehicles it is applied. So all these outcomes are being tested, right? Similarly, if I test the outcome of a parking policy, I need to include this variables inside our model, so that we know that if I change the price of parking, what effect it will have, right? So these are the different things that could be tested. So according to that, I will select a model. Now, this is one way of explaining this. The other is, of course, if I have enough data, that means if I get a sample data set, then I may go for a micro simulation. If I don't have sample data and my sample data is very sparse, I may go into zone-based models, like the 4-step model where we use a gravity model for distribution. We can go into that kind of model instead of a location choice model, right? So depends on what approach, what is the context, and what kind of resources that I've got. Based on all this, we will take a decision. And there is another decision, what a decision point that you can consider, that is, will I go for a standard forces travel demand model, or should I go for activity based model? So that is again depends on the outcome that you want to be evaluated, right? So again, activity based models requires a lot of data to be evaluated. So if you have enough access to this kind of data, then it shouldn't be a problem. Okay, I think that takes care of this question. Can I move on to the next question?
Could you please explain cordon line?
Okay, cordon line is a important part of the transportation planning process. It determines that, okay, for what boundary we are planning that particular, we are developing our plans. For example, if I'm doing a transportation plan, if I don't consider any kind of boundary, that means the number of traffic analysis zones there could be lots and lots of traffic analysis zones. But if and also the urban area's character changes. That means the central area is very dense, and gradually the density reduces, right? So the thing is, if I do same amount of survey, same kind of information collection in all the area, then probably it may not be cost effective. So instead, what we can do is, we can do the core area survey very intensely, and we can do the surrounding area survey at a, we can take the basic data sets, basic data for those areas and so on. Now, how will you do that? That means there would be, the size of the traffic analysis zone needs to be changed, right? So in the core area, we have smaller traffic analysis zones. In the larger area, surrounding area, there are larger size traffic analysis zone. Now, if I want to even go further, that means at one point I have to put a boundary. So beyond that, how will I consider? That means because people will be traveling, like the case of highway, people will be keep on traveling from outside the area, inside the area, to the the central area, and we need to have an estimate of that. So that is where cordon comes in. So we have to put a cordon, and along that cordon line, wherever it cuts the different highways, we do an estimate of how many vehicles are coming in and how many vehicles are going out, and of what modal characteristics they of that particular traffic. And that actually help us to identify. And when we do a cordon point survey, we do also we also take a record of the number plate, so that we understand which vehicles are going inside the city and which vehicles are going outside the city. So because we are doing the cordon point survey simultaneously at different locations surrounding the city, and we can understand that, okay, a vehicle getting in over here, and after a certain amount of time, if it doesn't goes out from any one of the other points, that means it has gone inside. That means a person has maybe have come to work or to shop inside the city. So these estimates could be done using this cordon point survey, and the cordon is basically that boundary beyond which we can assume that the area is external, and we can create either a circumference around our existing area, or we can even break that into certain segments, and we can create very large zones and saying that how many people travel from those zones to the center of the urban area. So this cordon point actually, or cordon line actually help us to create this boundaries. That is its purpose. Okay. Next question.
Sir, next question is by Neil Roy. He has asked how the demarcation of suburban region can be done in a city.
Could you repeat, please?
How the demarcation of suburban area can be done.
I think your voice is breaking up. Anybody can?
Sir, she's telling how the demarcation of suburban area can be done in a city.
Okay, so suburban area, there are two, of course, there are two basic approaches. Of course, we can follow the administrative boundaries. There is municipal area, and beyond the municipal area, we can say that we can call it a suburban area, or, if it's part of a bigger urban development area, accordingly, we can decide. So there are different nomenclatures as well. We sometimes use the term peri-urban area, and suburban area is usually, when we talk in travel demand management terms, we sometimes associate it with sprawl kind of development, right? So this is one issue that we sometimes face. But at the end of the day, suburban area is where people these are external areas from the city, the core city area, from where people travel daily to the city for different purposes. And the boundary, there is no fixed limit. You can go with the administrative boundaries, and then administrative boundaries plus, peri-urban area, and then beyond that you can consider it as a suburban area. So it's up to you to decide, but there is no hard and fast rule for that. And also there is another point that I make point out, that sometimes what happens, depending on the kind of growth that has happened, for example, growth has happened along a transit corridor. For example, there are a lot of rail lines, heavy rail transit lines coming to the city, and along the lines there is a lot of settlements that has come up. So all this could be called as suburban developments, even though they are pretty far away. That means they are not within a particular, within a particular designated area, or a designated, that development area, or a development urban, based on a particular development authorities area. It could be even beyond that, but because people travel every day and all, we can even call that a suburban area. Okay, so next.
Sir, there's a question by Kabilan, who's asking if it is correct to apply disaggregate mode choice models to our aggregated traditional four-stage models.
Actually, aggregated four-stage model could be done in an aggregated way. Four-stage model could be also done in a disaggregated way. So four-stage model, if I am generating trip rates for each disaggregate group of people, then automatically we can conduct a disaggregate a mode choice model. If it's not, then we cannot do that. That means we will end up with just broad percentages of this modal choices that is there. But the problem is that is where this micro simulation comes in. If you want to apply this models like disaggregate models, then it's better to do a micro simulation. You get a segregated population for that particular area, and then we can apply that data. And it's otherwise we can apply this disaggregate mode choice models, but the problem is we need to have at least based on the structure of the model and the kind of socioeconomic characteristics that we use in the model, this model has to be there, in that what to say, that when you have surveyed at least those particular groups, and you have assumed the same grouping for that particular zone for which you are predicting the travel demand, or for predicting trip generation as well as mode choice out of that. So this is the issue. So the main problem that happens is whenever we do a survey, we do trip generation rates based on household sizes, or based on either your, based on certain income groups maybe. But the problem is if we don't combine different socioeconomic categories, you don't really have a disaggregate data set. So that is the main problem that you have to overcome. So that's why this micro simulation comes in. Okay, next.
There is a question by Gurdeep Singh Bagga. Dear sir, can you please specify about some institute or organization who do survey of traffic flow at city or district levels in India?
I think, well, that's not part of our course, but yes, there are several companies that work in this particular field. They do surveys and all, and not only that, and you can, do a Google search for that. And there are big offices like RITES and all. They regularly conduct traffic, this kind of plans, and they have their own survey teams as well. So you can look into that. Okay. Any other question?
When we have census data and NSS, is there a need for sample surveying for basic details of the population? Which is more accurate, sample survey or census survey?
Actually, I think the question is a bit, ambiguous, but I will still try to answer. There is census survey is done all over the country, and there is a standard format. Based on that, data is collected. And as we were discussing, it collects data on certain certain socioeconomic characteristics of the people and all, and there is no locational attribute to that data. That means we know that for a particular ward, how many groups are there and so on, but beyond that, we don't have any other locational attributes. But when we do a sample survey on our own, or if it is done from the government's end, the idea is there is some amount of geographical information along with the data. That means it's not only talks about which ward this population or this person belongs to, but we can even go for a micro details like, okay, in a particular, in a particular grid, what is the person, where is the location of the person, right? So that is, additional data which you can actually utilize when you are developing a more micro scale model. And otherwise, sample data sets also is good because you can collect, so many other socioeconomic characteristics which you have not collected in the standard, sample survey, right? So additional data can be always collected using this sample surveys, which are, conducted regularly. And based on that, we can also develop these disaggregate models. We can develop this micro simulation models or any kind of, even a 4-stage model, non-disaggregate ones with some amount of disaggregation, we can also develop like that.
So there's a question by Pranav who's asking which accessibility measure is better to be considered, or it depends on context only.
It depends on context, it depends on data availability, it depends on many things, but I think we shouldn't go into accessibility today because I think there was, I remember another question on accessibility, but because we are still doing that assignment, we are not going to explain that, but in the next session, we will definitely take up accessibility because it's module 5 and we will explain that over there. So, but yes, it definitely depends on the context.
The next question is, how does the activity pattern of commuters impact travel behavior and vice versa? Any case studies relevant?
Can I answer that part first? One part,
Okay.
So activity pattern, again, has not been covered yet. It is going to be covered in the final 2, modules, rather the pre-final module. Or the final model, I don't exactly remember, but we will do detail. We are also going to explore the Cube software, where we will also talk about how to conduct activity-based modeling using the Cube software. We will also do a little bit details about how activity-based modeling is done. So yes, so activity-based activity pattern basically refers to not only about the trip, but about when it starts, where you are going, and what are the sequence of trips that are there. And a sequence of trip could be called as a tour, right? Because you are starting from one point, going somewhere, and again returning back. But after that, you spend some time at home, again go out, and again return back. So this entire thing pattern is the activity pattern. And this activity pattern includes multiple tours, and multiple tours include multiple trips. And the entire day's activity pattern, that means how you spend your time throughout the day, that actually is the question. That means it is based on, like normally most people, will get up in the morning, they will spend some time at home, then they will go to, walking people, of course, they will go to, work. And while coming back, they may go for shopping a little bit, or they may just come back from office as well. So, whereas in a weekend, the pattern may be totally different, right? Similarly, if I take the case of a student, he may go to school in the morning, and then he may be accompanied by somebody, and then again he comes back, and after that he goes for some sort of coaching or some sort of training, as other kind of training, and then again he comes back, and then he spends time at home. So see, the activity pattern for a worker and a student varies. The activity pattern varies over different time periods, and not only that, activity pattern varies over different days. And a person, the assumption is, and also it varies as per different socioeconomic groups, right, or household groups and all. So the idea is, whenever a person is spending time, he is trying to take multiple decisions at one point of time. He's trying to decide on his mode. That means how he should reach the destination. Sometimes the decision is the destination is also variable. That means, should I go to watch movie at a certain theater, or because it is too far away, I think that okay, it's the nearby theater is not that good, but because it's nearby, I will go there because I have to do some other task. See, that other task plays a role, right? And or if suppose somebody goes to office, he tries to manage that shopping by trying to get out of office a little bit earlier, or using a certain mode which will make him to reach that particular shopping destination at a certain time, which would not be possible if he uses a bus, right? So all the mode choices, the destination choices, the time of the day when he starts the journey, all these things are interrelated, right? So this is the entire activity pattern. So this activity pattern, if I work with that, obviously my predictions for the travel pattern for a particular area would be much more accurate. One small example: if you go by car in the morning, it is likely that in other than exceptional circumstances, you are going to go to from work to shopping and then shopping back to work using the same car. You're not going to leave that car in the office and come back, right? But if I use a trip based model, it may predict that that while going it was car, but from from that office to the shopping center, the prediction is bus, which is not possible, right? But because it is an independent prediction for that particular state, it is like that. And when you accumulate all this data over over multiple individuals, this may add up to a lot of errors. So that is where activity based predictions actually improve, right? So this is one. The other is, in today's context, activity based modeling is also gaining from this theory of activity based modeling was there for a long time. But now it is gaining prominence because we have got machine learning algorithms, or we have computer this computational power has increased quite a bit, and so we are now able to run this kind of models very easily, and that is why this kind of models are gradually getting popular. Okay, next question.
There is a question from Neil Roy. In the developing country like India, there is a change going in urbanization pattern, on the basis of which factors one can differentiate between urban and suburban area of a
I
metropolitan.
think this I just answered that. I answered that little bit ago. I think Somnath asked that.
Another question is from Manu Rajput Kotwal. Sir, can you please suggest a book in relation to subject which is easily available, which we can buy?
It's not there. It's not there. That's why we are preparing this course, and eventually at the end of course we will like to prepare a book out of it as well. So right now there are a lot of transportation planning books, and then there are a few land use planning books, and land use modeling books in the Indian context are not there. And the references that I've given, there are some good references over there which you can utilize, but these are all Western written by Western authors and all. So definitely, the context and all would be different. So that's the that is the limitation that we have to overcome. So there is books on transportation. There are several books on transportation, but there are several books on land use as well. But again, land use related books in Indian context is much less. But land use transport interaction books, the ones which I have shared in the reference, those are available. But other than that, in the Indian context, there is no specific book which could be suggested as a textbook. Any further questions? Shutishmita, there was one part of that, there was some other part of that question. I asked you to just say one part.
Yeah. Any case studies relevant to the previous question?
That activity-based model,
Yes.
we will share that when the time comes, because we have not yet to cover that particular module. When that, when we will cover that in our lecture, then obviously there will be references attached with that. And
Uh,
anything else?
yes. In case of studying travel behavior of a specific group, college going students in an education oriented city or region, what can be the key features for the analysis?
That's very specific question. I think again, I think once we have done with the lecture, you'll be able to answer that on your own. So I will not go into specifics, but you have to think about, like, whenever activity-based model is done, we have to understand what kind of activities are generated, how these activities are scheduled, and so on. So which we will discuss later on. So this would be specific. What you have to do is it has to be specific for the student groups. That is all, and the activities that are possible, the destination choices that are possible are based on that particular city, which is the educational hub you want to say, right? Suppose you are doing the model for quota. So in that particular case, quotas, land use structure has to be taken. So it depends on that. So we will discuss all this when we do activity-based model. You can put up the question again, no problem. We'll discuss at that point of time. And finally, any other question?
There's a question from Gurdeep Singh Bagga.
I,
Dear sir, what should be ideal way to address dynamics of growth while allocating land use, as transportation routes such as national highway or state highway triggers or modify land use behavior?
yes, obviously means, see, growth is dynamic. The land use transformation process is dynamic, right? It's not like it, even though when we do our plans and models, it is always done at certain intervals, right? That means we do it for a 5-year period or 20-year period and 30-year period, but actually the process is very dynamic. That means it changes every day. Every day somebody buys land, somebody constructs a house, right? So it's very dynamic. Now, the question is, you are saying that there are transportation highways coming out of the city, and a lot of growth happens in those particular areas. So how does it plays a role, right? So that is the question. So the thing is, whenever in our lecture, when we have talked about urban, growth directions and all, I again think this is part of module 5, if I remember correctly. But still, little bit we can answer. That is, uh, uh, for example, this whenever we are whenever a particular area is growing, so then we need to understand that why it is growing in that particular direction, and is there any problem with that. That means it may be fine. That means if I allow the growth, it may grow unhindered in that particular direction, but it may cause other problems. So it may have environmental effects and so on. So that is where we need to be very careful about what has to be, where we need to put up some amount of control and all. And that is where urban growth direction assessment, urban land suitability assessment, urban land use land cover assessment comes into play, right? So all these things will help us to determine in which direction the city is growing, what is the dynamics of change. That means how much amount of land is being converted every year or so, and in which direction it is happening. So that will give us an idea if it is because of certain purposes and all. And that itself will help us to, and based on the ecological features or the environmental benefits, this kind of growth will happen. We can put up some amount of control, and that will help us to design this area in a more sustainable manner. So I think that more or less covers your question, right? Okay.
Last one from the Manu Rajput Kotwal.
Mhm.
Can you explain iterative proportional fitting 3D? I am facing problem in segregating row and column in the given table.
Again, I think we have given a full example of that. But in iterative proportional fitting, what happens? There are 3 dimensions, right? When there could be 2 dimensions, there could be 3 dimensions. The meaning is, whenever it's a single 2 dimension, that means we have got 2 levels of categorization, right? 2 levels of categorization means what? Means we have gender as well as education or income level, right? Or household size, gender and household size, right? Now, if I add the third dimension, which is socioeconomic, this income pattern, then we have now got three categories. So we need to know people from each group. That is, how many people belonging to of a particular gender, belonging to a particular household size, and of a certain income category. This is the figure that I want, right? So this is the kind of data that is, so this has got three dimensions to it. So now what happens when you do the sample survey, then you collect the data, then you will definitely find there are some amount of people who belong to this particular category. So this is a three dimension, right? Now, when you want to do iterative proportion using a three-dimensional table, so in addition to the two dimensions, that rows and columns, you need to have the third dimension, which is called a slice. Now, slice basically means it's a combination of two of those parameters. So that means in addition to the control totals, that is either gender, how many male and female, what are the total values of male and total values of female, or the total values of household size, that means how many from each household category, what is the total number of people, plus total number of people belonging to each income category. That means for these are the single dimensional control totals. In addition, we have to have two-dimensional control totals. That means how many people are in. This has to be from the survey, means from the census data. That means for the main data set that you have got. That means in a city, you need to have data on people belonging to certain socioeconomic group, income group, and gender, income group, and this household size, then household size and gender. So each of these subgroups, we need to also have this control totals. If you have these two sets of control totals, then automatically you can do a IPF of three dimensions. But if you don't have, nothing to worry. You can always go back to your two-dimensional table. You can always consider this once you have done a two-dimensional IPF, you get those values. That means how many people belong to age group, gender, and a particular household size, if these are the two categories that we are considering. So we know exactly how many people are there in that particular group. We take that particular value. That means this is a sort of two-dimensional total, you can say. And then we can always take this as one group, this this entire thing as one group. We take it as a single dimensional thing, and then we add another row, which is the income, and then we do again a two-dimensional fitting. But if you do it in this way, the accuracy levels are a bit low. So that is also how you can manage this. I think this more or less shows you, but you can just put start putting it in table formats. You can do it in both ways, and you can compare the results to see. You will see that if you do a three-dimensional one, it will be more accurate. But if you do it in a converted two-dimensional way, that means we add these two characteristics and make it into one characteristics, one group, then automatically that also is one way to take care of that. All right, so you can test with, you can do some examples on your own as well. All right, so I think we are almost at the end of our time. Any final question? Any final question?
There is no question.
Okay, so I think that's the end of our session today. So I hope you are well prepared for the next session. And I would again like to explain that this course has been designed for different groups of people, means from different levels of understanding, and you can pick up the relevant portions whichever you require for your own requirement, either for your research or for conducting a consultancy, like if you are developing mode choice models in your particular thesis, or you can look at the mode choice module, and you can learn from that. Or if you are doing some sort of residential location job, working on that area, you can look into those particular modules. So independently, these modules are also you can study those modules, but you can always refer back to some of the basic, like the first module and the second module. This gives you a basic understanding of the overall modeling process, and that will make sure that you understand the nitty-gritty, and so that in future when we refer to certain terms, you will understand those references. That's it. Okay, thank you for attending this live interactive session. So see you for the next time. Thank you. Shuman, you can conclude the